Hello students, we're back to our second segment of chapter 18.2. We're still talking about chemical nomenclature, and we recently talked about, you count the number of carbons, so there's 3 carbons. You look at the Latin prefix, that's prop. It's got all single bonds, propane. Sorry for the noise in the background, the dog is drinking. It's obnoxious. And there's a little bit of a different thing going on here. Now, 1, 2, 3, 4, 5, 6 carbons. Okay, so we're going to name it using the prefix for 6, which is hex. And we know that since there's a double bond, it is an alkene, E-N-E, since it's a hexene. But that doesn't tell us a whole lot about hexene. You see, the double bond could have been here, or here, or here, or here, or here. Oh, no, not there. It can't double bond to a hydrogen. You see, there's lots of different kinds of hexenes out there, so we have to name it specifically. We're going to name it based on where that double bond is, and it is on the 1, 2, 3. It's on the 3rd carbon. Therefore, we're going to name this 3-hexene. Sometimes you see it as a 3, comma hexene, depending on the textbook. But the dash is most common. You're going to call it 3-hexene, and that'll help you on the homework, particularly application section question, I believe, number 1. And a lot of chemists abbreviate. Now, if I went and I looked online, let's go to Google, and I typed in on Google, let's see, I'm going to go to pentane. What am I going to get? Wow. Thanks. Pentane. Well, that doesn't tell me too much. Well, actually it does. See, a lot of organic chemists they're so lazy that they don't actually even write the carbons in or the hydrogens. So every bend is a carbon. And they don't even write the hydrogens. They assume you are so good at assigning hydrogens that you can just tell how many hydrogens this thing has. And this here indicates a double bond. And so this is actually pentene. 1, 2, 3, 4, 5 carbons. And more specifically, it is 2. Pentene. There you go, a little bit of cursive. It's 2-pentene, and that's because the double bond is on the 2nd carbon. So, anyway, that's a little bit more about nomenclature. There's some other things here, like aromatic hydrocarbons. Aromatic hydrocarbons are cyclic, so they are arranged in a circle, and they pool their electrons together, and of course, I ask here, does anyone remember the term for electrons that rotate between 3 or more atoms? I do. I hope you do. That term is delocalized. And so you have a delocalized electron in here, and the rest of these are single bonded. So kind of strange. This whole delocalized electron things, but aromatic hydrocarbons is how they make anything with a smell. Even nature has aromatic hydrocarbons. So if you think about the smell of banana, why does it smell like that? Well, it's an aromatic hydrocarbon. And so we can actually artificially manufacture the smell of banana by making the same hydrocarbon. That's how we get something like smensels. You know, those pencils that you smell. It's not because we surround them with bananas for days before we before they ship them off. It's actually because they dip them in the hydrocarbon that's responsible for the smell of banana. So anyway, kind of cool. Hydrocarbons on Earth. Many hydrocarbons are found as petroleum, also known as crude oil. It's complex but can be used profitably. For instance, in this case, gasoline. So we take it out of the ground, sometimes out of the ocean, and we harvest it, sell it. The unfortunate side effect is when the hydrocarbon is burnt. Okay, we'll take a look at this hydrocarbon. Once it's burnt, all of these carbons split apart. The hydrogens bond together. That's fine, because hydrogen is nothing. The problem is the carbons bond to oxygen, making carbon dioxide. And a lot of people think that a increase in the CO2 levels affect the environment. So you can see how China, oh boy, the U.S., China, Russia, India, these have millions of metric tons of carbon dioxide pouring into the atmosphere. And it's higher than it's ever been in the history of the Earth. And so a lot of nations came together to sign this Kyoto Protocol to reduce emissions over time. And they have a lofty goal of somewhere around 2050 to have no carbon emissions, yada, yada, yada. But carbon emissions are definitely something that developing nations are using to become more developed. And that countries like China are using to become some of the manufacturing capitals of the world. Not anymore, though, because of this coronavirus. I hope you haven't ordered off of Wish.com anytime recently. I don't think it's going to come to you. So, sources of hydrocarbons, of course, we talked about petroleum, crude oil. We have refineries, which use a something called, this is my mother telling me to wash my hands, oh boy. Refineries use what's called fractional distillation. It's not perfect. It doesn't make gasoline 100% of the time, but you can break apart petroleum, which are these long strands of hydrocarbons that have developed over pressure, which I believe is from the flood. Of course, if an evolutionist would believe the pressure happened over time. But anyways, the refineries will use fractional distillation. Some of it will become gasoline, some of it will become other kinds of synthetic oils. Some of them usable, some of them not usable. And maybe you've seen a refinery. I know that every time I visited Philadelphia, there's a massive refinery. Very cool. Cracking is a process in which hydrocarbons are heated and cracked to become smaller. This increases the chance of becoming gasoline. So you have this massive hydrocarbon, that's just what I was talking about. And it's heated, it cracks apart, and becomes two different things, potentially gasoline. And so, anyway, that's just a process, the cracking process. Take a look at this GIF here. I'll let you watch it twice. Looks like we're getting a little toasty here on Earth. Should we be concerned? Well, a great deal of attention is focused on the greenhouse effect. CO2 is significantly lifting the average temperature. Is it natural? Well, that's not for me to tell you. I think you need to do your own research on that. I do think that CO2 being a greenhouse gas allows heat to be trapped in the atmosphere and not to be released back into outer space. And is it natural? Well, the amount of carbon dioxide in our atmosphere is certainly not natural. We can actually dig down and find ice from 1,000 years ago. We can look at that ice and record the amount of carbon dioxide levels over time, and it's always been pretty consistent. Now we have a lot of carbon dioxide in our atmosphere. But is the heating natural? Well, take a look at these two different things. The medieval climate optimum. 200 years ago, it was so warm that it beats our warmest year on record. Well, there was no carbon emissions then, or very little at the very least. Or the Little Ice Age, a period so cold that the Thames River in England froze. Now, Thames River has never been recorded to have frozen. It's my understanding. Actually, during the medieval climate optimum, oh, I'm sorry. I must hear it. It says 200 years. I misread it. It's not 200 years ago. The medieval period is not 200 years ago. That was the Industrial Revolution in the 1800s. Medieval period was about 200 years worth of climate, where actually they have some record of in northern Europe, where it gets very, very cold. They actually were able to successfully grow some plants that are tropical. That's how warm it got. Well, your thoughts? Well, I can't really ask you your thoughts right now. But here's my thoughts. I think that we should try to curb the use of carbon dioxide, because if we, even if it's not affecting the earth and we get rid of it, it's gonna allow us to have a cleaner, healthier environment for all of us. So I do support non-invasive, of course, environmental efforts, and I hope that you should be a good steward of the earth as well. Well, anyways, that's the end of the lecture. A little bit of everything about naming hydrocarbons and about the different climate periods, about CO2, about cracking, various things. Make sure you do section review 18.2 for homework as well as the 2 application questions. Hopefully they won't give you too much trouble. And we're going to start on 18.3 when we get there. Just check your lesson plans and your syllabus. All right. Well, stay safe, stay healthy, and hopefully I will see you guys sometime soon.